Welcome. This video is going to talk about spontaneous processes and the idea of entropy, which is a little bit different than enthalpy, but the two are definitely related. So changes in both enthalpy and entropy determine if a process is spontaneous or not. Enthalpy, we already know, is the change in energy of a system during a reaction or process. But entropy is a measure of the number of possible ways that the energy of a system can be distributed. So entropy is directly related to the freedom of a system's particles to move and the number of ways these particles can be arranged. So it's all about randomness or disorder. More disorder, more randomness, more choices, more energy, that all increases entropy. So things that will increase entropy are state. Gases will have more freedom than solids. Volume, if you have more space, there's going to be more freedom. The number of particles is going to give not more freedom, but more possible combinations. And energy always increases movement. So, of course, it'd be greater freedom of movement and possibly more combinations as well. So, again, we can think of entropy as a measure of disorder or randomness of the particles in your system. When particles are more spread out, they have more disorder and greater entropy than when the particles are forced closer together. And the second law of thermodynamics says that spontaneous processes proceed in such a way that the entropy of the universe is increased. Now, the entropy of the universe is going to be the entropy of both your system and the surroundings. Remember, when we talked about enthalpy, we're talking about the system increases, the surroundings decrease because that energy has to come from somewhere. But when we're talking the universe, then both your systems and surroundings are part of the universe. So if you can increase the entropy in either your system or your surroundings or both, then you may have a spontaneous process because you may be increasing the entropy of the universe. So entropy of the process will tend to increase during a spontaneous process, most often when a process is exothermic and very often when the entropy of the system increases. Now, is that 100% of the time? No, but if both of those occur, if both the process is exothermic and the entropy of the system is increasing, for sure the process is spontaneous. And if only one of those is true, there's still a good chance the process is spontaneous. To know for sure if it's spontaneous or not involves a lot more calculating work and this concept of something called free energy, which we are not going to get involved with here. But we can make a pretty good guess on what's happening to entropy. Okay, remember, enthalpy for a system is equal to the enthalpy of the product minus the enthalpy of the reactants. So when you're looking at entropy for the system, you can do the same thing. The entropy of the products minus the entropy of the reactants should equal the entropy of your system. So if the entropy increases during a reaction, if the disorder increases, then the entropy of the system is going to be positive. If the entropy of the system decreases during a reaction, then the entropy for the system is going to be a negative value. And again, we can predict if many changes will increase or decrease the entropy if we just think about what's happening to the particles and if the freedom of movement and possible combinations will be increasing or decreasing during that process. So let's look at a few of these. Changes in state. If you vaporize or melt something, those are both endothermic processes. You have to put energy in. So these are actually the reverse of what we usually think of being spontaneous. But in this case, the energy increases movement to the particles. It increases possible combinations. It definitely increases freedom of movement. So the entropy of the system increases during vaporizing and melting, and we expect it to be a value greater than zero. Condensing and freezing, on the other hand, move particles closer, decrease the energy, decrease the freedom of movement. So during condensing and freezing, the entropy of the system decreases and is less than zero. Dissolving is another common process. Dissolving a solid or liquid almost always increases the freedom of movement. Okay, usually when something is dissolved in a solid, when either a solid or a liquid is dissolved in another substance, it has greater freedom of movement. You basically have increased the volume. So entropy of the system almost always increases in these situations or is a value greater than zero, as a positive value. Dissolving a gas, though, decreases the gas's freedom of movement. So in this case, we'd expect the entropy of the system to decrease or be less than 0. And in a couple other cases, is if there's no change in state between your product and your reactant side, if you look at the number of gaseous particles on the product side compared to the number of gaseous particles on the reactant side, if the gaseous product particles exceed the number of gaseous reactant particles, we can expect the entropy of the system to be greater than 0. It will have increased during that reaction. And since temperature always increases movement of particles, then we can also expect the entropy of a system to increase anytime the temperature of the system also increases. And that's a quick introduction to spontaneity and entropy.